So let's now look at part B, image formation in a convex mirror. Is that okay? And now we are saying that for convex mirror, irrespective of the location of the object position, the image will always be erect, virtual, and diminished. So we are saying that for convex mirror, irrespective of the object location, the image is always erect, virtual, and diminished. Is that okay? That irrespective of where you put it, the properties of the image will basically fall under erect, virtual, and diminished. How do we draw then the ray diagram? That if I have this as my convex mirror and I happen to place my object here, light rays will come reflected. If it is parallel, it will be appearing to coming from what we are calling focal point. If this end of curvature, and then what will happen is that I will have light rays from here. It will move along on the same path. The intersection of this will give us the image. And here we are saying that the image is the properties you have been mentioning. You can see here, yes, it is erect or upright. And then two, you can see that it is virtual. Okay? And then you can see that it is diminished. So those are the basic image construction ray diagram for our convex mirror. Is that okay? Don't forget, we are going to look at the application of all the curved mirrors, the convex and the concave mirror in the next part. As for now, let's first look at the linear magnification. What is linear magnification? We can say linear magnification is the ratio of image height to object height. Is that it? That means that linear magnification is equal to image height over object height. Is that okay? Or another person can say linear magnification is the ratio of image distance to object distance. That is linear magnification can be equaling to image distance, if it is V, I can say that out of object distance U. Is that okay? Now here, if you're using denotation, I can say H out of H naught. Is that okay? That one is also what we are calling linear magnification. So if they ask you to define linear magnification, it can either be the ratio of the image height to object height, or the ratio of image distance to object distance. That is linear magnification. And then let's look at the expression for linear magnification. How do we get the real expression for linear magnification? We shall say, consider a ray from a finite object of height h naught incident at the pole of the concave mirror as forming an image. Forming an image of height h as shown below. Okay, so we are going to consider this ray diagram here. If at all I have this, I have my object here, and then I have ray diagram. This is reflected there, and we said this angle here, this angle here will also be equivalent to that angle there, will be equivalent what? To theta. And then if I have that, I can now say if this is the height I'm talking about, h naught, and now this is the distance of the object U. Now where is the image first of all going to be formed? And then we can say, if I also look at the light rays passing through the center of curvature along with the same path. Of course, we said if the light rays passes through the center of curvature, it will move along with the same path, such that my image is formed here of height h, and then this one here becomes my image distance v. Is that okay? The object was here, I looked at light rays, is then at the pole, it will make the same angle. And then if the object is here and the image is here, that means that OP is the image object distance, and then if we look at the image being formed here, and then IP is the image distance. So, using that diagram, can we prove the expression for linear magnification? We can now say, if I look at this one O, and then this is point X, this is point Y, I can say from triangle OPX, what is tan theta? Tan theta is equivalent to opposite, which is OX out of adjacent OP, and that is the same as saying tan theta equaling to H naught. OX is the height of the object out of adjacent, that is U, equation 1. And then also from my triangle IPY, we shall say that tan theta as well is the opposite, which is equaling to IY out of the adjacent, that is IP. And then you can say tan theta equaling to IY is H and IP is V, equation 2. And then you can say that equation 1 is equal to equation 2. Is that okay? And then from there we can say H naught out of U is equal to H out of V. Okay? When we rearrange this, we shall have V out of U is equal to H out of H naught. Isn't it? Where V is image distance, out of this is object distance, and we are saying it is equal to this is image height over this is object height. And this is what we are calling magnification M. Is that okay? So that is our expression for magnification, either image distance of object or image height over object height. That is magnification. Thank you.